Now we're going to factor each polynomial function completely and then sketch its graph. Remember our chart for factoring. We look for the GCF first. Once we pull out our GCF, we look to see if it's got 2 terms, 3 terms, or 4 terms. If it's got 2 terms, we look to see if it's a difference of squares, a difference of cubes, or a sum of cubes. If it's 3 terms, we can use the snowflake method, grouping method, or box method. If it's 4 terms, we're using the grouping method. So the first thing I want to do is factor out the greatest common factor in this problem. And I could pull out a negative x, and that will leave x to the third plus x cubed minus 9x minus 9. Since the first factor has a degree of 1, it's finished being factored. But I have an x cubed here. So I have to ask myself, is it 2 terms? No. Is it 3 terms? No. But it is 4 terms, so I will factor by grouping. Negative x is still a factor, so I'm going to leave it out front. Let's factor the first 2 terms together. This is x squared. Let's factor the first 2 terms together, x cubed plus x squared. And the second 2 terms together, negative 9x minus 9. In the first 2 terms, I could take out an x squared. We're left with x plus 1. In the second 2 terms, I could pull out a negative 9. And I'm left with x plus 1. Now let's group these together. We have x squared minus 9 as one of the factors, and x plus 1 is the other factor. Again, I have to continually check to see if I'm finished. Now because this second factor inside the brackets has a degree of 1, it is complete. But I have to check this degree of 2. So I ask myself, how many terms is... Obviously, we've already taken out the GCF. This has 2 terms in it, so I'm going to check to see if it's a difference of squares, difference of cubes, or sum of cubes. Well, obviously, it's not difference of cubes or sum of cubes. It's a difference of squares. So we have negative x. The x squared minus 9 is x plus 3 times x minus 3. And then this is times x plus 1. The degree on this polynomial is a 4. Since it's even and it reflects, it's going down to down. And the roots are 0, negative 3, positive 3, and negative 1. So let's graph these points. Okay, this is a graph that is moving down to down. So we're starting down. These are all single roots, so it's just going to go through these points once, no bouncing. Comes through here, and back down from here, down to down. In the second example, again, we have to follow our flow chart, GCF. Notice I could pull out a GCF of x in this problem. That will leave me x squared plus 2x minus 8. I'm through factoring the x to the first power, but this is a squared, so I'm going to check and see if it's 2 terms, 3 terms, or 4 terms, if I could still factor it. This is 3 terms, and I can still factor this. This would be x plus 4 and x minus 2. So the roots are 0, because x equals 0, x equals negative 4, and x equals 2. This is a graph that is positive. The degree is 3. So this is opening down to up. Let's plot our points. 0, negative 4, and 2. These are all single roots, and that's important to note because that just means I'm not bouncing off anything. I'm just going to go through them. And moving down the up. So we start below the x-axis because it's down, up through this point, down through this point, and up through that point. And we're done. Number 3. First thing I want to pull out is the greatest common factor. In this case, it's going to be negative x squared. That's going to leave x minus 4. Set each factor equal to 0 and solve for x to get the roots. So x equals 0 and x equals 4. Now x equals 0 is a double root because of the 2. So roots are 0, and that's a double, and 4, which is a single. The degree on this polynomial is a 3. This is a negative graph, so it's reflecting. So this is a graph that is moving up to down. So let's plot these points, 0 and 4. Now we have a double root right here at 0. This graph is going up to down. So I'm starting here up. It's a double root. So once it touches it, it's going to bounce one time. That means it's coming back up this way. And then it's going to turn because it's got to go through here. It's got to go through 4. And that's what this graph looks like.